Okay, folks, let's go ahead and get started. I want to apologize for today. We started out today with technical issues on my part. I had connectivity issues, and so it took us a while. Took me a while to get that worked out, and so I wasn't able to post for you. And then I come to find out later that the Edpuzzle folks, their server went down. They just had a whole lot of people going on, and so you couldn't get on at that time afterwards either. So I apologize for that. Hopefully, it looked like most of you were able to get the work done. If you could not get it done, to try to get it done by the end of the morning today, so that you can start this new video. Hopefully, fingers crossed, we don't have issues, but with everyone else getting online, all the other schools going to online classes as well, I think we're going to face these problems more often. Hopefully, we'll be able to deal with it pretty quickly, or they will be able to deal with it pretty quickly, so that we don't get these interruptions. Okay. But we did lose roughly a day. I think that's going to push things back a little bit. So the exam then, I had a few people ask me already. The exam then will be on Friday. Okay, so we'll definitely have the exam on Friday. We'll review on Thursday the for the exam. And so what will happen is with the review, I will post. We'll just meet as a class during our periods, and so second period we'll meet during the second period time, which is going to be 8:50 to 9:30. Third period we'll meet 9:35 to 10:15, and then fifth period from 11:20 to 12. You obviously will not have a video on that day, and so we'll meet review on Thursday. Everyone's welcome. Everyone is encouraged to come. At that point, then we'll conduct the review very much like we've conducted the review in reviews in class. But this time, what you will do then is you'll type your questions into the chat box, and then I will take the questions and I will answer them, and we'll go for the full period. And then what you'll do then is if you have more questions, we don't get to your questions by the end of the period, I am available after school on Thursday, 3:15 to 4:15, to take more of your questions that you may have. Okay, so that's how we'll handle the review. I'm going to try to keep things as similar as possible to what we did in the classroom to make things straightforward for you. Obviously, the change then will come in how we deal with the exam. Again, I'll post the video for you tomorrow, hopefully this afternoon, if not tomorrow. I apologize for that. Again, the technical issues on my side made it difficult for me to get that video posted for you. So I'll get that video posted for you, and that'll explain for you how we'll do the exam. Essentially, it'll be roughly a 15 question multiple choice exam. From there, then what I will do then is I will choose a question from the multiple choice, and it'll be different questions for different people, obviously. And then I will ask you to show me the work for that, and then you'll post that work for me, and then I will check that. But again, like I said, I will I'll lay that out for you in the video to make it clear for you what you'll have to do. So that, again, I'm going to try to keep it as similar to what we did in class as possible. And obviously, what will happen is I will proctor the exam that day. We'll all meet on Zoom here, and then I'll go ahead and proctor the exam. Again, the procedures will be laid out for you in the video, and then I'll take any questions you may have about the exam on Thursday as well when we review. Okay. So the exam then will only be on Chapter 12. It'll be a mix of multiple choice and calculations. And again, I'll point out to you what how we'll deal with the exam in the video and take your questions on Thursday. Okay. All right. So with that said, then I want to go ahead and finish up this chapter by working out this problem. I asked you to work out this problem towards the end of the period, towards the end of the video yesterday. So I'm going to go ahead and I'm going to work out this problem for you now. It helps us then to review everything we've talked about up until this point in the chapter. Okay, and so let's go ahead and let's take a look at this problem here, and let's work this one out together. Okay, so let's go ahead then. Okay, all right, so with these problems here, make sure you keep in mind then with stoichiometry, what we always want to make sure we do is you always want to make sure we have a balanced equation. And here they give us an equation. So they tell us then that we have silicon dioxide, as a solid. We're going to react that with the carbon, okay, also as a solid. Oops, sorry. And that's going to produce for a silicon carbide, it's a solid, and carbon monoxide gas. Okay. All right, so on Friday, if you're given an equation, even if it looks balanced, make sure you check to see that it's balanced. Okay, so here the balance equation, then it's going to be 1, 3, 1, 2. And again, a quick check to make sure everything is balanced. And we got 3 carbons on the left, 3 carbons on the right, 2 here, 1 silicon on the left, 1 silicon on the right, 2 oxygens on the left, 2 oxygens on the right. Everything's balanced. Okay, so we have the balanced equation. Then what I would do then, if again, this is something that if you cannot keep track of things in your head, I would just write it out just to make sure that you have it. Okay. All right. So we were told then that we start out with 50 grams of silicon dioxide. So that's what we have right there. Okay. We are told that we have excess carbon, and then we are told then that we have 27.9 grams of silicon carbide that is produced. Okay. And so this is the 27.9 grams of this product right there. Okay. All right. And so what they want to do is they want us to calculate for the percent yield. Okay. And so real quick, just to review, remember to calculate for the percent yield, and here they're asking you about the percent yield of silicon carbide. And how do I know that? Because they give us the amount of silicon carbide here. And so what you have to be able to recognize is that this amount here, what they give us here is what we refer to as the actual yield. Remember, you will be given the actual yield. You have to be able to identify it. Okay? So they tell you the yield of silicon carbide. Obviously, there will be a yield of carbon monoxide, the other product, but they're not concerned about that right now. They want you to find the percent yield of silicon carbide, and so they give you the amount of silicon carbide that forms. Okay, so understand this: the actual yield will always be given to you. So you just have to make sure you can identify this actual yield. Okay? Which means then, to calculate for the percent yield, you need to find the theoretical yield. They will never, if they ask you to find on the exam, if you are asked to find the percent yield, it is up to you to calculate for the theoretical yield. You have to find the theoretical yield first. They will give you the actual yield, and then you use those two numbers to find the percent yield. So in a problem where they ask you to find the percent yield, they will give you the yield of one of these products. That particular yield will be the actual yield, and so therefore it is up to you to find the theoretical yield. Okay. All right, so how do we go about finding the theoretical yield? So we need to find that. Well, the theoretical yield, remember, is just the amount of product that is expected to form if everything goes right, 100% of the reactant turns into product. That's your theoretical yield. That is the upper limit that of product that will form if everything goes according to plan. And again, like I pointed out to you yesterday, obviously in real life, real lab situations, not everything goes according to plan. So you can strive for 100% yield, and thus the theoretical yield and the actual yield will be exactly the same. But in reality, they will never be the same. There are many, many factors that go in to determining the percent yield. Please make sure you're aware of what those factors are. Okay. All right. So to calculate for it first, then to calculate for the theoretical yield, we must first determine the limiting reagent. Okay. Now this will depend on the on what they give you. Okay. But here they tell you start out. So the limiting reagent, remember, is the reactant that runs out first, and when that runs out, no more reaction. So that particular reactant will determine then how much product will form. And so here we are given 50 grams of silicon dioxide, and here we are told that we have an excess of carbon. So luckily for us, we won't need to calculate for the limiting reagent, because if this particular reactant is the excess, therefore then the limiting reagent has to be silicon dioxide. Okay? So there it is. So there's no need for the calculation here. However, if they had given us an amount here, if they had told us how much carbon was used in this particular reaction, it's at that point you have to do the limiting reagent calculation. Okay? And so we'll do a problem like that in just a moment. Okay? But make sure you keep this in mind that if you're given amounts for both of the reactants, you must do this reaction. In this particular problem here, you do not have to calculate for the limiting reactant because you're told that one of the reactants is in excess, so the other one must be the limiting reactant. So there it is. Okay? So which means that we can go straight now to calculating for the theoretical yield. So to get the theoretical yield, you have to find the limiting reagent first. Once you have that, you can go ahead and calculate for the theoretical yield. And so you can go ahead and calculate for the theoretical yield. Okay. And that yield, this calculation then is simply a stoichiometric conversion between your limiting reagent and the product that you're looking at here. Okay, so it's going to be then, we're going to start out with then the conversion then, we'll start out then with 50 grams of silicon dioxide. Okay, and we're going to convert that into grams of silicon carbide. Okay, so that's the conversion there that we're going to do. Okay, that and what we'll end up with here is the theoretical yield of silicon carbide. Okay. All right, so with that said, let's go and plug this in. So the mass, so molar mass first, divided by molar mass of silicon carbide, which is going to be 60 grams. So we're going to divide by 60 grams of silicon carbide. Then we need the mole ratio between these two here, which is going to be a 1-to-1 mole ratio, which is 1 mole of silicon carbide over 1 mole of silicon dioxide. And then finally, we're going to multiply by the molar mass of silicon carbide, which I have here is 40 grams. So we're going to multiply by 40 grams of silicon carbide over 1 mole. Okay, we get our theoretical yield here as being 33.3 grams. This is our theoretical yield. This is our actual yield. So this is the theoretical. All we have to do then is divide these two numbers, okay, and you'll get our percent yield. So the last calculation we're going to have to do here is what's highlighted for you in red. So the percent yield of silicon carbide in this reaction is going to be the actual yield, which is 27.9 grams of, sorry, hold on, this of silicon carbide all over the theoretical yield, which we calculated for here, which is 33.3 grams of silicon carbide. And as you notice, the amounts are not the same, and we expect them not to be the same. Okay. All right, so you plug that in, then you get a yield then. Let's go write this in, of 83, a percent yield then of 83.7% for silicon carbide. And so this again represents a very substantial, very good percent yield, okay, for typical reactions. The ones that I've run in lab, even on my best days, I was getting roughly about 60, high 60% yields. And that was with a reaction that I knew what was going on. I knew what to do, and I ran it very carefully. So this would then be a fairly good yield. Okay, so yields tend to be fairly low depending on the reaction that you do and how many steps in that particular reaction. Okay? All right, very good. So with that said, then let me ask you to do this. Let's work out a couple more problems here. Okay, just to give you some practice. Work out a couple more problems. Let's take a look at number 35. So get your book out, number 35 from your book on page 375. So let's go ahead and work this problem out really quickly. Okay, and then when we get back, take about 4 or 5 minutes to get this done. When we get back, we'll work out this problem together. Okay. All right. Let's go ahead and then let's take a look at this problem here. So let's open up to page 370 on page 375. They tell us then at number 35 that we're going to ask. They're asking us to find the percent yield of copper. I'm sorry, the percent yield of copper when we are given that we're going to start out with 1.87 grams of aluminum with an excess of copper 2 sulfate. Okay, so they give us the reaction there, and so let's go ahead and write this down, and let's work this problem out. Okay, so we have then aluminum reacting with copper 2 sulfate, okay, as a solid, okay, to form then aluminum sulfate. Aluminum sulfate, SO4, as an aqueous solution. And then I'm sorry, this is AQ, aqueous, sorry. And we end up with our copper, solid copper right here. Okay. And the balance equation is going to be 2, 3, 1, 3. 2, 3, 1, 3. And just to check, make sure you check to see that's correct. Okay. All right, so with that said, then what do we have here? And again, at some point, folks, you don't have to write what I indicate here, but I'm writing it out for you because this is something that you should probably be keeping track of in your head. Okay. All right, so we're told that we start out with 1.87 grams, okay, of aluminum. Okay, we have an excess of copper 2 sulfate, and then we were told then that we have 4.65 grams of copper. Okay, so this is the amount that we start out with. Hopefully you recognizing that this will be our limiting reagent, so we don't have to calculate for it. Okay, if this is our excess, this has to be our limiting. So aluminum will be our limiting reagent, and what we are provided here then is the actual yield. So this is the actual yield. Again, you just have to make sure you identify it in the problem. Okay. All right, so that's what we have moving forward. Let's go ahead then and let's calculate for the theoretical yield because they want us to find the percent yield of this reaction here. All right, so theoretical yield then, we start out if we have 1.87 grams of aluminum. We want to find then the mass of copper that will form if all of this gets used up as a limiting reagent. So we're going to do our calculation, our stoichiometry. Okay. And so then we start out, divide by the molar mass of aluminum, which is going to be 27. 1 mole of aluminum, 27 grams of aluminum. The mole ratio then is going to be a 2 to 3 mole ratio. Okay, so we're going to be multiplying by 3 halves here. Hopefully you see then why we are multiplying by 3 halves. It's going to be 3 moles of copper over 2 moles of aluminum. And then finally, then molar mass of copper, which is going to be 64 grams over 1 mole. Okay. All right. So that sets up the problem for us. And so with our theoretical yield, then we end up with 6. If you plug everything in, we end up with 6.65 grams of copper. So first, so here again, we don't have to calculate for the limiting reagent. We start out here by calculating for the theoretical yield. So this ends up being then, folks, right here, this is our theoretical yield right here. That's the amount of copper that we expect to form. So this is our theoretical yield. Okay. This is the actual amount that forms. And so if you want to think about it, this is the theoretical yield is going to be what we expect. This is the expected amount. Okay. And this is what we actually obtain. This is the actual yield. This is the actual versus the expected. So this is our expected amount versus the amount that we actually got. Okay. All right. So therefore, then to calculate for the percent yield for copper in this problem, so the percent of copper in this problem, then it's going to be the actual, which is 4.65 grams of copper over 6.65 grams of copper times 100. And then we get our percentage then as being 69.9% yield for copper. Okay, so hopefully you got that. If not, make sure you write that down and use that to help you study for the exam on Friday. Okay. All right. Let me ask you. So let's do one more here. Let's do one more. Okay. All right. So if you notice, I posted the chapter 12 material for you already. I posted for you online. Please make sure you take a look at that. So there is one problem in that chapter. So let's go ahead and take a look at this here. There is one problem in that chapter that I would like us to work on because it'll give us a chance to practice. Okay? So take a look at this problem here. let's start working on this problem. I'm running low on time here. So what I would like you to do then is set up this problem, work it out, and I will work this problem out for you tomorrow. So please make sure you have this on your paper. And then I will also assign one more problem for you to do from the book. And that way then we'll be able to finish practicing calculating for these percent yields and doing these stoichiometric calculations. And then we will be able to start chapter 13 tomorrow. We'll review on Thursday, and I hope then that at that point then you'll be well prepared. And I think you should be, for the most part, at this point, well prepared to do with any problem I give you on the exam. Okay. All right. So let's finish up with this problem here, and then what we'll do is we'll pick up this problem tomorrow. And then please make sure you also do the assigned problem today from your book, which I'll assign at the end of this video. And then we will start chapter 13 tomorrow. Okay. All right. So fingers crossed, folks. Hopefully we won't have any of the technical issues that we had today. Things hopefully will get back to running fairly smoothly tomorrow, that you'll be able to get this work done. Okay. When you watch this video. So hopefully you'll be able to watch this video and not worry about the technical issues. Okay. And then I will see you folks tomorrow. Okay. Or hopefully today after school, I'll be able to see you. Okay. I'll talk to you soon. Bye.